Okay, so hi everyone. We have this question on binomial which reads find the coefficient of x to the power 5 in the expansion of 1 plus x power 2 divided by 1 minus x to the power 2 as well. So the first thing we're going to do here is we're going to write this as 1 plus x raised to the power 2 multiplying with 1 minus x raised to the power -2. Since 1 minus x is in the denominator, we can just bring it up like that, then we just raise it to a negative power. So now, what is expected of us is to expand both of these. For the first one, we can expand the whole expression. For the second one, we can only expand as far as the term x to the power 5. Okay, so the formula we'll be using is, if you have, for example, 1 plus, sorry, let me use ax raised to the power n. So the expansion for this can be given as 1 plus anx plus n minus 1 a squared x squared, all this is over 2 factorial plus n minus 1 n minus 2 ax to the power 3, sorry, a to the power 3 x to the power 3, all this is over 3 factorial. Next term will be n minus 1 n minus 2 n minus 3 a power 4 x power 4, and all this is over 4 factorial. Okay, so since we also want the term x to the power 5, we can say it continues. So we'll have n minus 1 n minus 2 n minus 3 n minus 4 a to the power 5 x to the power 5, and all this is over 5 factorial. So we need all these because remember we're looking for the coefficient x to the power 5. Okay, so how is this going to help us? The first thing we're going to do is let's find the expansion of the same expansion this for this one. By doing so, we're going to say the value of n is -2, while the value of a is -1. So everywhere where there's n, let's replace with -2. Everywhere where there's a, let's replace with -1. Let's see how it goes. So for this expression, please note that this is just the formula that we're using to find these particular expansions. So this is our formula. But now let's use it to find the expansions for these two. So I'm starting with this one. We have 1 minus x raised to the power -2. So like I said, a is -1, n is -2. So let's expand. We'll have 1 plus a is -1, n is -2, x plus same thing here. So -2, -2 minus 1 is -3, a is -1 squared, then we have x. 2 factorial is just 2, this is x squared. Come here, n is -2, n here again -2, so that's -3, here -2, so that's -4, A is -1 raised to the power 3, x power 3. All this is over 3 factorial. 3 factorial is 6. We come here. So for this part, again, n, -2. Put -2 here, we get -3. Put -2 here, we get -4. Put -2 here, we get -5. A is -1, x to the power 4. All this is over 4 factorial. 4 factorial is 24. Okay, now we need for this term as well. So n, as usual, -2. Put n here, -3. Put n here, -4. Put n here, -5. Put n here, -6. Now, here where there's a is -1 raised to the power 5, x to the power 5. All this is over 5 factorial, which is 120. Okay, so let's simplify now. 1 minus x raised to the power -2. So since we're simplifying, we can have it as 1, that's the first term. Multiply these two, of course, we'll just get 2x positive. Then for this part, this is negative, negative, positive. These two can cancel with these two. So we just remain with a 3 and this 1. So we just say plus 3x squared. Remember, negative, negative, positive. These two cancels with that 2. We just remain with 3. This one here is -1 squared, so it's just 1. Okay, we come here. For this part, negative, negative, positive. So this cancels with the 6. 2 times 3 is 6, cancels with the 6. We just remain with -4 times -1, which will give us +4, x to the power 3. Come here. We have a 24. How do we get to 24? We know that, first of all, these 4 negatives, 1, 2, 3, 4 negatives, will give us a positive. This is a positive, this is a positive. 2 times 3 is 6. 6 times 4 is 24. So this whole thing can just cancel with this 24. Hence, we just remain with 5. 5x to the power 4. This is supposed to be power 4. I forgot about the 4 there. So -1 to the power 4 is just 1. So we have that. We come here. So for this part, how can we kill the 120? Remember, 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 120. So what will happen is this. These two will give us a positive. These two will give us a positive. These two give us a positive. So we have positive value throughout. So 6, this times this is 6, times this 24. 24 times 5 is 120, meaning that this whole thing will just cancel with 120. What do we remain with? -6, -1, which is just positive. Sorry, this is supposed to be a positive here like this, which is just positive 6x raised to the power 5. So the expansion of this guy just reduces to this. Now let's have an expansion for this guy. We have 1 plus x raised to the power 2. If we replace the first term is okay. Here where there's a, remember our a is 1, our n is 2. So that will just be 2x. Come to this term, where there's n, we'll put a 2, so that is 2. 2, the 2 that we'll have here, where there's n, we'll cancel with this 2. So we just have 2 minus 1. Let me just write it. What I'm saying is we'll have 2, open bracket, 2 minus 1. A, remember, A for this one is 1. So that's just 1 squared, x squared. And all this is over 2. Meaning that 2 minus 1 is 1. So these two will cancel, giving us 1 plus 2x plus x squared. Okay. So now, remember, these two are multiplying. So let's multiply them, then we see how we can get the coefficient of x to the power 5. Okay, so the expansion for this one is this one here. The expansion for this one is this one here. And of course, we're just from expanding, so I'm sure you know what I'm talking about. Now we're looking for the coefficient of x to the power 5. Now this bracket is multiplying this bracket. So we're not supposed to multiply these two brackets. What we can do is we just multiply certain terms that will give us x to the power 5. Remember, to get to x to the power 5, we need to make sure that when the powers of x add up, what we should get is 5. So it's just a matter of pairing them, or pairing some of them. 1. If I multiply 1 with 1, I want to get x power 5. 1 times 2, I want to get x power 5. 1 times 2 times 3, rather, I want to get x power 5. So I hope you get the idea. The idea here is that 1, if it multiplies with 6x to the power 5, then I'll get an expression which has x to the power 5. 2x. If I multiply 2x and 1, I want to get x power 5. 2x times 3x power 2, I want to get x power 5. Unless if I multiply 2x times 5x to the power 4, then I'll get x to the power 5. So let's pick the pairs that will give us what we are looking for. If I multiply 1 with 6x to the power 5, I'll get an expression with x to the power 5. What else? If I multiply this guy with x power 4, I'll get x power 5. If I multiply this guy, the power 2, if I multiply the power 2 with the power 3, I'll get x power 5. This simply means that we want to be using this guy. Sorry, supposed to be not this one. Sorry. This one's supposed to come here. So we're not using x power 2 because x power 2 times x power 2 is x power 4. But x power 2 times x power 3 is x power 5. So let me call this A, let me call this B, let me call this C. So let's just pick out what we've just mentioned. For A, we are saying 1 is multiplying with 6x to the power 5. Of course, there will be terms in between, but we're just interested in power 5. For B, this one that we have here, we have 2x, which is multiplying with, what is it? 2x is multiplying with 5x to the power 4. There are terms in between, but we don't need them. Then for the last one, we have x squared multiplying with 4x to the power 3, like that. So if we multiply these two, what do we get? 6x to the power 5. They're like terms, so we can just add them now. This and this, what do we get? 10x to the power 5. Multiply this and this, we'll get 4x to the power 5. So if that's the case, add these numbers here, we'll get 20x to the power 5. Since we're looking for the coefficient of x to the power 5, and the coefficient in this case is equals to 20. So this is our answer. Thank you very much. I hope it makes sense. In case you have a question, please feel free to drop it in the comments. Have a good day.